Okay, Steve.
Okay, and I'm looking at the punter's eye view on my other laptop, and it appears to be okay. We have problems with
and I can see it too.
Weird boxes appearing yesterday. It doesn't seem to be a problem today. So a very good day to one and all. And for those who don't know me, I am chair of the QRP Club, and I wasn't going to speak formally this year, but unfortunately, Dennis Anderson, G0FUW, who had volunteered to do this and put a lot of work into preparing the talk, is unable to deliver. Dennis isn't very well, and we wish him a very speedy recovery. And I think if he isn't in the audience, he's certainly registered for the convention. So if you are listening, Dennis, a speedy recovery from one and all. So as I mentioned in the introduction, getting started with SMD was in the top 10 topics of sort of what the members wanted to hear about. So there's clearly a demand for people to know more about this. And I am by no means a black belt in this. So I'm grateful to having support to help out with questions and things at the end. But hopefully my experience as a relative newcomer to SMD will help others to give it a go. My advanced thing doesn't want to work. It does now. So yeah, I've explained why you're stuck with me and not Dennis. Dennis, by the way, was the owner of Kanger UK Kits, and Dennis was taking it down a track to produce more surface mount technology kits and make them available to the amateur community, and was quite successful in doing that. So due to ill health, he's had to call it a day with Kanger, and the company is now under new ownership, who very good to know is with a QRP Club member. Paul, who currently runs Phoenix Kits, has taken on the Kanger mantle and will be merging the two businesses together. And he's asked me to still share details of the Kanger kits, because he does intend to still make them available. The website's up and running, but he is in transition, so please bear with him while he takes over. But he should be up and running as Kanger very soon. So why did I volunteer to fill the gap? Well, first of all, as chairman, I feel responsible to deliver something. But probably more importantly, nobody else stepped forward. So it was I decided to take it forward. But joking apart, I have built some kits, and I've even run a couple of surface mount buildathons. Witness the picture on the slide there. That's Ali Hughes, whose call sign evades me, but I know Derek, her husband, is G7LFC. A supporter of Liverpool Football Club for his sins. So that was Ali's first attempt at certainly at surface mount construction. I'm not sure if it was the first attempt at all construction, but we had quite a number of people at that buildathon, and we used some different methods of construction. And one of the guys who attended that was so enamored with the techniques that he went away and bought himself all the gear, and came back the following year when we did a different kit, and joined in again, and said he'd found surface mount to be a revelation and he thoroughly enjoyed it. So I think that's a pretty good endorsement. But anyway, let's see where it takes us. So that's the sort of list of topics that I'm going to cover, and I won't read them out to you. We'll go through in time. But I would draw attention to the cartoon. Sadly no longer with us, but GW3COI was a great contributor to Sprat with these little cartoons, and I think this one was most appropriate for SMD, and certainly the magnifier will come in very handy when you're doing the building. I have to say, I prefer my radios to be radio sized rather than pocket sized, mainly because I've like Pete, I've got the FFS, the fat finger syndrome, and trying to navigate menus and buttons is not my thing. I'd much rather have switches and knobs and dials to press, but that doesn't mean to say the components inside need to be very big. And I've got a couple of things that I've built with SMD in slightly larger boxes than they need to be, just because I don't lose them then, and I can find them when I need them. So let's see what move on. Fairly obvious question, first of all, what are these surface mount devices? Basically, the best description I found is that they are components with no leads. Not entirely true, because as you can see on the screen, some of them have got these little tiny legs more than leads that sit on the printed circuit board for soldering. But your resistors, your capacitors, and certainly some ICs don't have any leads to connect them at all. They just have metal pads. And they are soldered directly onto the PCB tracks. So on the same side as the track, you have the components, which seems a bit odd if you're building, used to building through-hole devices where you put the component on one side and solder on the other. And I think it was Charlie yesterday, ZL2CTM showed an example where he actually uses Veriboard, so a strip board if you prefer, with the copper up and solders to that. So that's a kind of surface mount technology in use, and it is very successful. It actually works really well. And if anybody's got our Sudden kits, it's a shameless commerce division, as they'd say on Solder Spoke, our Sudden kits, the Limerick kits, they use a kind of surface mount technology as well, in that they use conventional components but soldered on the top without any through-hole connections. So yeah, surface mount is a technique rather than a particular way of working, but these devices are specifically designed to be soldered on the copper. And some advantages, especially you can actually see the tracks and see where things are joined up, and I think it helps to see what's going on sometimes. Now, some of these devices are really tiny. There was a picture on the web of literally a finger, sort of fingerprint, if you like, just the top of the finger, that had 5 of these devices sitting on top of it. I wouldn't even dream of building something with devices that size. Some of them are much better, and I forget the designations, but I think it's 1206 is very manageable. And the one on the slide there with the I don't know, it's 270 or Z70 marking, these are quite reasonable size things. You don't really need a magnifying glass to see them, but you might need to want to use a magnifier to fit them. We'll come on to that in a little while. So some of them, yes, they are tiny, but you don't have to use those minuscule ones, which you know, like the sort of a grain of rice size of things. We did some building, and a guy came with an SMD kit that he was building, and then came back the week after and said, "Has anybody found a resistor that I dropped?" Well, these things, you know, perhaps if you're on your hands and knees with a bright light and a magnifier, you might stand a chance, but the ones I've used, the ones that Kanger Kits use and so on, you don't tend to get into that territory. No, I was shocked. I had in the back of my memory that surface mount had been around for some time. I hadn't actually twigged that the first time I saw it was in Sprat 59, which was way back in 1989, which feels like ancient history. I'm sure we've probably got some members that weren't born in 1989 these days, but Bill Mooney, G0FUW, was a member of the club, and he wrote this article, SMT, SMD, QRP, which is a nice sort of trip off the tongue, because he'd started this little company called Blue Rose Electronics, and he was advocating the use of surface mount devices. And if you've got the archive, by all means, you know, dig that out in Sprat 59, have a read of it. It's a good paper. It's a good introduction to what this is all about. Yeah, Blue Rose Electronics, they sold some little kits. He sold parts and things. And I have to say, I think Bill was ahead of his time. In 1989, a lot of people thought this was sort of crank technology and really would never catch on. And you know, why did we need to worry about it? Then on to 2001, when our founder, George G3RJV, did a presentation at 4 Days in May over in Dayton. And he did a paper called Introduction to Surface Mount Construction. And if you've got access to the proceedings, again, I would recommend it. It's a thoroughly good read. And associated with that, George produced a little kit, which was an RF probe, an oscillator, a PA, and a low-pass filter. If I think it was even a receiver in there. Very simple circuits, but using these surface mount devices to prove that you really could do this. It wasn't beyond the realms of a fantasy that you could build QRP circuits using these types of devices. There was also coverage in Sprat 108. So again, if you've got the archive, dig that out, have a read. One thing I must stress, and I checked with Graham before I did this put this presentation together, there are no kits left. So please do not ask Graham if he's got any of the kits left. They've all gone. And George's little booklet that went with them is also not available. So if you go to Sprat 108 and see the advert, I'm afraid they're not there. You can't, we can't recreate that, but it does show that, you know, that this is not new. It's been bouncing around for a while. Although I don't know if you can see it on the screen, but George started his presentation with a quote, as he often did, but this one was from W.C. Fields. And it said, I've seen a lot of change in my time, and I was against all of it. And I think that sums up a general feeling towards surface mount that sadly a lot of people just dismiss it and don't want to consider it. But there we go. There's some sort of reference material for you to go back to if you want to do some back reading. So I suppose that brings us on to this question: why would we, you know, inflict this thing on us? Why on earth would we get involved in new technology and use surface mount devices? And the first reason that's often trotted out is about component availability. There's many of the devices that we've been used to using are no longer available in the sort of traditional leaded configurations. Pete Giuliano quoted fairly recently the MC1496 mixer, which I think is a brilliant thing, and I've used it for, well, more or less since I came into the hobby, and I'd one in my HW8 if I remember rightly. It's a great mixer, and I've seen it in 2 different packages, and as far as I'm aware, believe Pete when he tells this, you cannot buy the leaded version you know, as a new device anymore. You can get it in surface mount configuration. So it's the same mixer, it's got the same properties, it's just in a smaller package, and you have to use the surface mount technology approach to use it. But it works just as well, and there's absolutely no reason why we shouldn't be looking at that. So the direction of travel is that the traditional components will disappear. Now, I know for a fact you can still get old components in small numbers. I was looking for a dual gate MOSFET not long ago, and I found some. You could buy them in 2s and 3s, sort of small numbers, which was fine for what I wanted. But the price was astronomical. These things used to be, you know, £1 or $1 each. And somebody was asking about £12, I think, per device. And I thought, oh, I'm not going to do that. It really wasn't QRP prices. So I went down the route of using 2 single FETs and effectively made a dual gate MOSFET. And it worked very well. And certainly cost a lot more than buying the old devices. So the component availability issue is there. The cost is an issue. As I say, the older components will be available for a long time in small numbers, I'm sure, but you'll need to pay the price for them. The surface mount stuff, on the other hand, are cheap as chips, quite literally. They're very low priced and widely available. It's not so easy to buy them in small numbers. You might have to buy, you know, a larger number, but then, hey, you've got a stock then. And I think Charlie said yesterday in his presentation that he never buys single items. He always buys in bulk because A, it's cheaper, and B, you've then build up a stock, so you always got some in hand. Some people like the small size of SMD because they can miniaturize their radios, and we've seen some amazing projects that use that. Hans Sommer's latest QCX Mini, literally, you know, a fantastic featured QRP transceiver that you could put in your shirt pocket, never mind your jacket pocket. The mounting topper, all these little QRP rigs that use SMD. Tiny packages allow you to miniaturize the gear, and if weight and bulk is important to you, then this is ideal. There is a question mark against the next two. Do they give better performance? Sometimes is my experience. In the example that you've got on the screen, the low pass filter there, I think they do, because you haven't got all the stray capacitance of leads, and you've got nice neat packages. They work very well. The surface mount inductors I've come across, not so much. Hence with this one, they've used the standard toroids as kind of pseudo surface mount, and then capacitors, but it just shows what you can do as a hybrid approach. Is not to be ruled out. And again, a question mark on easier construction. People have got it in the head that it's really difficult to do. Hopefully when I've shown you a couple of techniques, you'll see that's not necessarily the case. But it's like anything else. If you've been used to doing through-hole construction, learning something new will feel difficult at first. And certainly the first project I did with SMD, I did not enjoy it at all. I did it and I completed it, but I didn't enjoy it. But as I've done more and found out better ways of working, I've found it to be quite an enjoyable experience, and quite amusing in some cases. But, we'll again come back to that. It almost flows. It's almost like I've made it work. What methods can be used? Well, there are three main ones that I've come across. Four actually, if you count the traditional one with a soldering iron and a bit of wire. You can use the traditional method absolutely no problem, and I think I've got some to show you that in the next slides. But the other method, which is a bit novel and not something you've probably come across if you haven't done this before, is with solder paste, and that comes in a syringe or sometimes in a pot. It looks like gloopy sort of PVC or PVA adhesive type consistency. With the syringe, certainly you just put a little blob of the paste on the board, and away you go. And the three techniques that you can use with that paste are the hot air gun, which is the one at the bottom right, sometimes called a reflow station. The top right is a temperature controlled oven. This is not a microwave oven. It's like you would use to warm up your pizzas or cook a bread or a ready meal sort of thing. I don't know, but it's not a microwave oven. It's a conventionally heated oven. I do like the note on the top there that says it's not for food, poison, lead, and flux. Somebody there obviously taking care that the family don't use it for the wrong reasons. And the final one, which is bottom left in the pictures, is a hot plate, and that looks like a fairly sophisticated bit of kit, doesn't it? It's literally a flat plate that warms up, and you put your PCB on the top of it, and it warms up and does the soldering for you. And that only costs £60. It's not a massive investment to go down that track. It's a big lump to have on your bench, but you know it's not going to cost you £100. That's what I'm going to say. And the hot air gun at the bottom, I think that's the one I've got actually, the Duratool. I think it cost me £50 or something like that. These are not expensive tools, and you will get a lot of use out of them. So cost, I don't think, is an inhibitor in terms of getting involved in this and giving it a go, particularly if you've got a club and the club wants to buy some of this to give it a go and give people some experience. Well, why not? So what equipment do you need to do this? Well, the absolute minimum is a good old soldering iron, preferably with a nice fine point. You don't want something going in there like a chisel, an old plumber's soldering iron that you pull out the fire or something like that, but a nice sharp pointed soldering iron. Some tweezers, very useful. You can see in the picture there, holding the component in place while you do the soldering. And Dennis used to provide us with tweezers, really good quality. I think they're actually medical things, but really good quality, nice sharp points, and easy to handle. And desolder braid is very useful. You'll see later why that comes in handy. But like any soldering job, you can make mistakes, and being able to recover that, I've found that the braid is a lot better. One of the reasons a solder sucker isn't necessarily a good thing is because some of the components, they're so small, will end up inside the solder sucker. So it's probably better with the solder braid. I've certainly got on better with that. And the magnifying goggles, the first time I did the project, I didn't use any magnifying goggles. I did use a magnifying glass to check joints and things like that. But having used them, I found them to be very, very easy to use and very helpful with less than perfect eyesight. It really does make a difference. And the ones that, again, Dennis used to provide, and I think they're the ones that are in there, you can flip the magnifier bit up out of the way so that when you're doing your general work, you don't need them down. You just flop them down when you're going to do some work. So really helpful. And I think, again, not expensive. I think they were maybe £10, something like that. Not, you know, it's not going to cost a lot of money to get going. Probably worth mentioning at this point the technique with a soldering iron. A lot of, and I certainly didn't know when I started. I just dived in and tried to, thinking, right, how do I hold the component, hold the soldering iron, and get some solder wire on there? You don't. The best way to do it is you tin the pad. You know, put a decent amount of solder on the pad where you're going to put the component. Hold it in place as per the picture, and then melt the solder so it attaches that one end very well. And then you can spin the board round or move your position, and then just solder the other one with the soldering iron and the wire. So you're not trying to do three things at once. And certainly in the early days, people were advocating all sorts of weird clamps, and there's quite a number in Sprat actually, where like a sort of nodding donkey, a miniature oil rig type thing that would hold the component down whilst you soldered it. Well, I don't know who it was that discovered that if you solder one end first and then do the other end separately, you don't need to hold them in place. You just use the tweezers, which you've got far more control then. So yeah, it definitely doable just with a soldering iron and some tweezers. And I'd certainly recommend, if you're going to give it a go for the first time, that's probably the best way to do it, and give it a try. Excuse me. If you're going to use the hot air method, or indeed for that matter the oven or the hot plate, which I'm not going to go into because effectively it's the same as the hot gun, but you're just using different methods for heating. It is a different technique, and initially I thought it was very laborious because you put the blobs of paste on the pads, and then you drop the component into place, and because it's kind of sticky, the component sits there. It doesn't fall off or anything, which is good. And then you basically heat the paste with the hot air or the plate or the oven, whatever, and it melts, turns into a sort of molten metal. I was trying to find, I had a video to show you this, but I can't find it. That when the solder paste melts, the components line themselves up using kind of surface tension, and it's the weirdest thing to watch, but I think it's fascinating. And the best descriptor I can give you, if you've ever seen the film Terminator, when the robot sort of gets all turned into molten metal and then reappears as a Terminator, it's kind of like that. It really is quite strange, but as I say, quite enjoyable and quite rewarding when you see all these components lining themselves up. And that is really where the benefit comes in. If you're doing one component at a time, which is how I started, it takes quite a long time and it does feel quite laborious. And then somebody said, why are you doing it one at a time? If you've got 20 resistors to fit, why don't you put them all in place and then heat the whole lot? And it's so obvious when somebody tells you something like that. Of course, why didn't I think of that? And heating the board either with the hot air or the other techniques, and all these things just being soldered at once is a revelation. It's brilliant. It works. You do have to go around afterwards and check that they've all done soldered properly. But again, come back to that in a moment. But it's great, it works, and I found it to be really good. The only problem I had was one, I didn't put enough paste on one, and when I brought the hot air in, it blew the transistor off the board and took me a little while to find it. But you learn from these things, you know. It's likewise the table protection. I learned very quickly that if you blow in hot air onto a PCB, it gets hot, and so does the table underneath it. And I actually made the mistake of trying to do it in a plastic tray first time, and yeah, the hot air won, shall we say. The tray did not survive. So I always use a piece of hardboard, just a couple of mil thick on the table. That gives enough protection. I guess in the old days, we would have had a nice tile of asbestos, wouldn't we? And probably, you know, not lived to a good old age to tell the tale. But yeah, hardboard works fine. It provides sufficient insulation and protection for even the dining table. Yeah, good old kitchen table technology, as George used to call it. So what sort of things can go wrong? These are the issues that you might come across. Some of them are common to standard soldering. You know, how many times have you made a project, wondered why it doesn't work, and then when you've inspected it, you find you've missed a joint? You know, it happens. We've all done it, I'm sure. I certainly have, and it can take hours tracking it down. And when you find it, you feel such a chump. But hey, you know, we're human beings. We make mistakes. So yeah, if you miss a joint with a surface mount, it won't work. It's as simple as that. It's just like any other solder job. You can equally get cold joints or dry joints, as we sometimes call them, where if you don't heat the solder paste properly, or indeed using the standard technique, if you get a bad joint, again, you might get an intermittent fault, or it might not work at all. So those things don't go away with surface mount. They're still with us, and something you have to be mindful of. You can get too much heat. You can imagine blowing hot air, and when I say hot, it is very hot. It's not just like a hairdryer. This is you know, there's some serious heat in there. You can melt things, particularly things like polystyrene or plastic components. Resistors and capacitors, ceramic capacitors particularly, and ICs tend not to be too much of a problem. But yeah, again, like conventional components, if you put too much heat on, you're going to destroy the components. I always quote this: the worst example I ever had was a guy who rested the soldering iron on top of a relay while he went to find his next components, and we just saw the soldering iron disappear into the body of the relay. And yeah, that involves some considerable reworking for sure. That can happen with hot air just the same. But the two things that are very specific to surface mount are these two things called tombstoning and bridging. I guess you get bridging with conventional, but it's not quite the same. The two pictures, the top one is an example of tombstoning, and you can probably see why it's called that. And in that heating process that I talked about, sometimes, I'm not quite sure why it happens, the component will just decide to stand up like a tombstone. So it's nicely fixed at one end, but completely missing at the other. These things happen, you know, and all you do is you go in with your tweezers and your hot air gun, and you rework it. You reflow the solder, pop it back down where it should be, and jobs are good. Similarly with the bridging, this is where your solder braid comes in. Again, when I started, I was quite fastidious with the IC pads, where you put a little blob of solder paste on each one and make sure it was nice and neat. And then somebody said, you don't need to do that, just whack it all in there, and if there's too much, go over it afterwards with a solder braid. And sure enough, that works. You know, you put a nice splodge of solder on there, solder paste, give it a good heat in. In most cases, it will form itself into nice little blobs onto the connections. But as in the example there's literally too much to do that. The surface tension isn't enough to draw it away. So you just go in there with the solder braid, reheat it, put the braid on. You might want to use an iron rather than hot air, and lift it off, and does a fantastic job. So in those respects, I think it can be quite much easier fitting these things than if you had to solder with an iron and a wire. You know, 14 pins takes 14 operations. Just squirt the paste on there, plonk it on, heat it up, jobs are good. So that's why I had the question mark. Is it easier sometimes with surface mount? Yes, it is. But sometimes it's not so easy when it tombstones and you have to rework it. So you would never get that with a through-hole component, that's for sure. So let's have a look at some examples of projects that you might have a go at, and I think all the photographs of my projects that I've done. This is an absolute ideal first project. If you want to have a go at surface mount, I would thoroughly recommend this, and it's a Kanger Kit. It's available in the US from Third Planet Solar, and I think John, who runs that company, worked with Dennis in Kanger to come up with this particular design. But you've got good size resistors, and as you can see, the majority of them are the same value, so you haven't got the problem of getting them mixed up. So it's quite easy to work them, and if you want to try different techniques, you can. But certainly building that with a soldering iron and a pair of tweezers, very easy to do. The trickiest bit, I don't know if you can see it down at the bottom left-hand corner, there's a diode, the D101, tiny little three-legged device. It gives you a bit of practice of what things, so you practice on the big chunky resistors, and then by the time you get to the diode, you probably think, oh, I can do this, this is a piece of cake. The kit includes a BNC connector and some Molex connectors at the other end, so you can tap off to an oscilloscope or to a DC meter, so you can measure the power, you can observe your waveforms. It's a cracking bit of test equipment, and a great experience of first-hand using surface mount technology. And if you might be able to see it at the top of the picture, it says it's a 20-watt dummy load. So for your QRP activities, Ssb or CW or whatever, this thing will sit and soak up the power quite merrily in these tiny little packages. And my experience of dummy loads is they tend to be quite big and heavy and chunky. Here's an example where surface mount helps us out. Some of these things are really useful additions to our kit bag. There was a review of this kit in QST, and I'm quite annoyed with myself. I couldn't find the reference. So if anybody's got a photographic memory or ability to find it, it's not so old that you can pull it from the archive. It's in the days of the sort of electronic mag. And I know I've got a copy of it somewhere, but like all things, when I tried to find it, I couldn't. So, but the review gave it a really good write-up and said much the same as I have, that if you want to try surface mount for the first time, go for it. This is a great kit to try. And so if you had a club night or something like that, when you're all allowed to gather back together and people wanted to give it a go, why not? And you end up with a very useful bit of test equipment at the end of it. So, who wouldn't want a dummy load in their shed? This one's slightly different. This is an example from the Radio Society of Great Britain, and it's a wideband RF amp, and it's got some different components in it. It says an IC. If anybody's familiar with the flat dual gate MOSFET sort of package, where you've got a little round button in the middle and 4 flat legs coming off the sides, that's the type of package this is. It's not tiny. There's a resistor, an inductor, and 6 capacitors, and they're all very well spaced out on the printed circuit board, which comes already with the kit. And I haven't tried it, but it occurred to me that this might make a useful amplifier for a receiver loop, because it's wideband. I forget how much gain it gives. Does it say on the description? No, it doesn't, but I think it gives a decent bit of gain. And I checked again before I did the presentation. These are still available. I'm not on commission, but the RSGB bookshop, if you go to the bookshop, I think in other items, kits, you'll find the page that's on the screen there. And I built this just to see if it would, it would work, and it did. So it only occurred to me the other day that it might actually make a useful receive loop amplifier. This is one of the kits that we used at one of our buildathons, and it's the old Sutton receiver by G3RJV, also known as the oh crikey, I forgot what it's called. It had other names. Was it the Neophyte? That was the other name it went by in QST and so on. couple of NE602s and a few other components, and you've got yourself a DC receiver. And I'm currently using mine in a transceiver with a sudden transmitter, and it works very, very well. Now, Dennis put this together, and I actually helped him with some of the development work. And the decision was to make it much bigger than it needed to be, to help people again try surface mount for the first time, or maybe the second one after your dummy load project. So you can see there's lots of space around the components. They're not all crammed in together, and you've got some Toco coils in there which are not surface mount, but they are infinitely better than any surface mount inductors that I've found yet. And we built, I think, about 16 or so of these in the build-a-thon. They all worked. There were some issues with drift, as there always is with conventional VFOs, but if you drive it with a DDS, it's a mighty fine receiver, and a good SMD project, and still available as far as I know through Kanger UK, as I say, depending on how Paul takes the business. And Third Planet Solar have still got them on their website as well. So give it a go. It's a nice little project, is that one. Now, this is another one that's certainly a step up from the dummy load, but again, we use this. The picture I showed you earlier from the build-a-thon with Ali Hughes and myself. This is the project that we were working on. It's a two-tone oscillator for testing your homebrew Ssb transceivers or transmitters, certainly. And this one does use some of the smaller size devices, transistors and ICs. But again, I think we built 12 or might have been 15 of these at the RSGB convention, and they all worked. Nobody had a disaster. I think somebody sneezed and lost a few components, but we had spares, so we were able to sort that out. And again, people tried using conventional soldering. They tried the hot air method, and all ended up with a nice two-tone oscillator. And I used mine in anger not too long ago. Joining some dots here, the simple Ssb transceiver that Pete Giuliano described in last year's convention, I used my two-tone oscillator to set that up, and very good it was too. So yeah, that's another one you might want to have a go at. Now, this was my very first attempt at SMD, and looking back, it was probably a silly thing to do. I wanted to give it a go, and this was a kit that came from Kanger, no longer available, or at least it's no longer shown on the website. It's called the Finningly 80 Meter Sdr, and it was came from a project, I think, from the Finningly Radio Club, and Dennis got permission to produce it as a kit. It's certainly a step up in complexity from those other ones that we've looked at. As you can see from the picture, there's less space to work. There's some fairly small components on there, and it took some doing. So I'd say this is maybe for your second or third project if you go down that route. But the fact that I completed it without any specialist equipment shows that it is buildable. Even someone with fat fingers like me, I think the only specialist equipment I had was a pair of tweezers, and yeah, it works. I had the SDR running. In fact, we used another variation of that in another build-a-thon with through-hole construction. Oh, what's happened there? Oh, don't know what happened there, guys. But, it threw me out. Yeah, that works. We used it, and the one that followed it was called the Acorn, and I think that is still on the website for sale. Now, this is a slightly different example. This is the Quartz transceiver, and this is by Colin Tuckley, G8TMV. Colin entered his kit into the construction competition last year for the QRP Club, and was a runner-up. And the panel were very impressed with what he'd done. it's a sort of an updated, improved version of the Rockmite, which Dave K1SWL has done many, probably thousands of. But Colin's taken the design, beefed it up a bit, SMD'd it, and produced a kit. Now his website still says there's a PCB and kits available, so I've put his website URL on the slide. So I'll leave that there for a moment if you want to make a note of it. And on that website, you'll find further details of the transceiver. I think he's got the circuit diagram and all the various things on there, and a bit of discussion of what he's changed. But Colin's used that out on the SOTA and various other outings and had some great fun with it. And again, I think it's probably a step up from, certainly a step up from the dummy load, but you know, still buildable. It's not horrendous. It's not like you've got something the size of a table to complete. And if you work through it methodically, I'm sure it'd be a good kit. So we're moving now on to the further information. Where can I go if I want to know more information? Well, this book for me is probably the best source you're likely to come across in printed form anyway. It's called A Practical Introduction to Surface Mount Devices, so it does what it says on the tin. It's written by Bill Mooney, who had I mentioned earlier as a club member and did the article in Sprat. I've put the US ISBN number there. It's no longer in print, this book, but you can track copies down on various online auction sites, or even I think Amazon do secondhand books and things, and links to secondhand bookshops. And as I mentioned, I think yesterday, quite often you find these sort of gems in the cardboard boxes under the table at rallies. So don't look at the tables that you're walking past. Have a look at what's in those little cardboard boxes underneath it, and you might find a copy of this tucked away somewhere. It really is worth its weight in gold. It's a very good resource. I'm not sure how much of this you can see if you're not an IRRL member, but I think the website is certainly available to anybody. I don't think it's in the members only view, but on the IRRL website, they've got a page about surface mount technology and the collection of articles pulled from QST. There's a 2-part primer, which it really starts from scratch and takes you through the basics. And then a 4-part series called You Can Work With It, which I think the emphasis on the word can shows that this is not something that's beyond the skill of any radio amateur. You can dive in and have a go, and I think there's some circuits and examples of things you can try. So good information available from our friends at the ARRL. I've mentioned Third Planet Solar before, a very good website as well as a shop. KC90N is the call sign. I think it's John that runs it. And he's got a page on his website called Working with SMD. And again, the URL is there, but if you search for Third Planet Solar and you'll find it without any trouble. And you can see from the picture, he's got some useful diagrams and talks about equipment and things you can use and techniques. So again, lots and lots of information that you can find. And I think that picture is a good illustration of comparing with a 1/4 watt resistor, the 2510 resistors, almost the same size, 1206, just a wee bit smaller. But by the time you get to the 0402, right in the middle at the bottom, yeah, I wouldn't be keen on using those myself, I have to say. A couple more references. If you like watching YouTube videos, Colin, I don't know if it's Colin or Colin, I like his his very relaxed way of explaining things. He's got some great videos of all sorts of radio stuff. He doesn't take himself too seriously. But that particular one, if you put Colin's Lab and surface mount, it'll take you to that video if you can't sort of get the link. And he shows you some of the stuff we've been talking about and sort of builds something on video, which again, picture paints 1,000 words, as they say. And finally, my sort of reference page, Sparkfun Tutorials, great website with lots of information on. And you can see there's stuff about hot air soldering, solder paste, using a reflow toaster. They use a skillet, which is a bit like a frying pan or something like that, which I think is a sort of homebrew version of that hot plate that I showed earlier. And they take you on to some other techniques and levels of complexity that are beyond me, quite frankly, but lots and lots of information available. I mean, there's tons. YouTube is full of tutorials, so don't think that you're on your own with this. You can certainly skill up very easily and get the information that you need. So a summary slide, and then we'll get on to some questions and answers, hopefully. So first point, this is nothing new. We've been using surface mount stuff for a long time, and the technology that uses components on the same side as the copper is not new. Some people even argue that valve building was surface mount because you literally soldered things onto tag strips and things like that. It is different to through hole. You've got to have a kind of slightly different mindset, but it is not too difficult to achieve. You can, a little bit of patience, a bit of practice, you will get there. And there is tons of help available, either in written form, YouTube, websites, you name it, it's all out there. And you don't need to start sourcing individual parts. You can get kits which come with the printed circuit board, the instructions, etc., etc. So you can really have a good go at it without too much investment in new equipment. But if you find that you like it, then yeah, again, it's not going to cost a fortune to re-equip to be able to do this. And as George used to say, I know George always used to like quotes, so I thought I'll quote George to finish off with this one. Plug in your soldering iron and begin. And hopefully you won't end up in the wee hours with an angry onlooker. But again, I think we've all been there at various times. So another cartoon from Sprat. So with that, I will stop sharing and ask if there are any questions.
Oh, brilliant, Steve. There are a variety of questions. There is a question that did show up in the chat that didn't make it into the Q&A, and I'll start with that one. And that is the G-QRP shop going to stock SMD parts?
I'm not aware of any thoughts of that. We have done that because the kits that were available when George did his talk were available through the shop, but we haven't had any specific requests for them thus far. But if there was demand, I'm sure Graham would have no problem in procuring some. And that's probably a good way of buying in relatively small quantities. If Graham gets a stock of 100, it's easy to then sell 10 or something to 10 different people. So we'll certainly look at that, and say we may be forced into that in the not too distant future as more devices become unavailable.
Okay, and then so going to the Q&A, John MOJFE, what temperature should your soldering iron be for SMD?
Hot enough. I've got a temperature controlled one, and it's almost permanently set to 400 degrees. Now, I've got no idea if it is 400 degrees because I haven't got a probe to test it, but I find that as a reasonable temperature to do most things. Occasionally, if you've got the larger components, you maybe have to crank it up a wee bit, but that's my starting point. And but I've used an old Antex iron, which it hasn't got any temperature control on it. You just plug it in and you get what you're given, and that worked fine.
Okay, and then Dave N2OA, are there any solder pastes that last? They do have a limited shelf life, and he's found it hard to use it before its end of life after he's bought it.
Yeah, I mean, I've had a tube now for 4 or 5 years, and it's still going strong. I think it's one of those things. If you can keep the lid on it and keep it sealed, it will be fine. But I haven't had an issue thus far. Probably next time I get it out, it'll be rock solid. But I don't know if Bill's had any more experience of that, but I've certainly not suffered from it.
Okay. And then we're using the hot air method. How do you focus that hot air to a single component without disturbing the others that are close by?
That's a very good question. Initially, particularly if you fit in a number at the same time, you don't need to focus it. You actually want the hot air spread over a wide area. So I tend to waft it around and try and raise the temperature fairly equally. But if you're going to rework one component, that maybe a tombstone component or something like that, you can put nozzles on the end of the gun, and some of them are actually shaped like the IC legs, so you're actually only putting hot air onto that very small area of the board. And it's like everything else, a bit of practice and technique. It's amazing how accurate you can be with those things.
Okay. Another question. What's your experience and ideas with ugly style SMD building? And this also ties into a comment in the chat recently about prototyping, which is similar to ugly style as well.
Yeah, I think it lends itself very well to ugly style building, because literally I think somebody mentioned yesterday about making grooves with engravers or Dremel tools or something like that. You can almost build the circuit as you're building it, and carve it out. And if you want another insulation pad, you just make one. I haven't gone down that route myself. I've only built kits. I haven't done anything from scratch. I haven't been that brave. But I've seen examples of others that have done that. In fact, Charlie, was it Charlie or Farhan yesterday? Somebody yesterday showed us a picture of a really ugly bit of amplifier work with an SMD transistor. And it worked brilliantly. So certainly no impediment to doing that, that's for sure.
Another question, do you have any recommendations for a reflow gun, particular brand or specifications for a reflow gun?
All I can tell you is the one I bought was the cheapest one that they had. I think it's Duratool. They do all sorts of tools and things that they're probably not going to work in an industrial environment and be used every day, but for hobby use, 50, 60 pounds, it does a great job. As far as specification, I would go for one that you can change the temperature and the airflow, because what I have found is that it's very easy to crank the thing up and get too much airflow, so it just blows the things off the board. So you need to back it off a wee bit, and being able to adjust the temperature. Again, it's one of those things, trial and error. You'll find a setting that works for you, and the sort of components you're working with. But I certainly wouldn't go and spend a fortune. Some of these things, I've seen them in catalogs that, if you're setting up a laboratory or an industrial workshop where you're investing for the future, yeah, you're going to buy good quality tools. But quite frankly, for something that blows hot air onto some paste, and particularly if you're doing it, you're not entirely sure that you're going to be stuck with it, go for the cheap and functional and give it a go. I actually did a review for the RSGB. It was printed in Radcom. And this is not a plug by any means, but Martin Lynch and Son do a range of irons. I think they're Huari, Hurai, and they were getting into the UK market. And I have to say, they were brilliant, really good quality, well built. They did the job. And the one that I kind of wanted to keep, a single unit that had a conventional soldering iron on one side and a hot air gun on the other. I think it was over £100 to buy, and Martin Lynch wasn't keen on letting me have it. They wanted to sell it on, so I had to return it, unfortunately. But they were good quality. They worked, and things. I don't think it did any better job than my cheap and cheerful. But it's that thing. You pays your money and takes your choice.
Yeah, in the chats, there's quite a variety of recommendations and such. Hopefully, we'll be able to save some of the chat here and some of the links. and some suggestions even using an embossing gun from a craft store and such. So yeah, if you're not watching the chats, there are a variety of nice suggestions there. Going on to the next questions. Any advice regarding removing SMD components from old PCBs and reusing them?
I think I'd be in the life's too short. But certainly, if there's something there that's very usable and you know, and something you know you're going to use in the future, actually quite easy to remove. Those little solder nozzles that you get on the end of the hot air guns, literally, I mean, they're sold as reflowing devices for fault fixing and things like that. And a club member and friend of mine, G0FUW, was a salesman for reflow devices and had some very sophisticated things. But they've got things where, you know, effectively you use hot air to melt the solder, and then a little sucker or a pair of tweezers just to pull the thing off the board. It's much easier than through-hole components because you haven't got that. You know, sometimes you get the plated through holes on the through-hole components can actually impede pulling the components out. Whereas with the surface mount, once you've got the liquid solder, literally just lifts off the board.
Could I come in and just say, one thing I found getting components off of large boards, I was given a whole load of boards with switches and lots of components on them. I used the hot air reflow device. Mine came from CPC Farnell, by the way, and that was about £60. Heat up an area, and what you need to do is put either a big bit of paper or something on the floor, hit it, tap the board, and they'll fly on the paper. You probably have components within solder as well, so they might need a bit more attention, but it's one way to stop them just going everywhere. You know, nearly do it on your knees, heat the board, bang it, heat it a bit more, bang it, and then see what you've got. So worth a try.
Cool.
Yeah,
I
mean,
I haven't tried it, but those hot plates, I imagine they'd be really good for taking components off, because you just sit the board on top, let it get hot, then pull the components off.
Yes.
The ones that you want.
One quick comment that I have is when I'm using or doing SMD construction, I use a pizza box. And there's a particular vendor here in the States, Papa John's, that all their pizza boxes are white lined. So you can see a contrast and everything, and would lend himself to what Bill had mentioned about, you know, having something with a tray edge around it. In fact, the surface that you're working on, if you can do it in something that has a tray edge, it's less likely that something's going to arc out of that and fall on the floor. And lending itself to the next question is how easy is it to rework SMD, and then do you have any tips on reworking?
Again, it very similar sort of comment. If you can melt the solder, it's dead easy to get the components off the board, and using the solder braid to remove any excess paste or anything, I find that's much easier than the conventional through-hole devices. So I certainly wouldn't have any problems with reworking, and I have had to when we did the build-a-thons. You know, the thought everybody puts everything in the right place first time, you know, dream on. Life isn't like that. So we had to do some reworking, and we found the hot air method perfectly acceptable and very useful way to get those components off the board, let it cool down, and then start again. And as I say, we did end up with, I can't remember, I think it was 15 or 16 working examples.
Another question, and I think this is an interesting one. How do you identify components as they're rarely marked? I do know that resistors are marked, but a lot of the capacitors are not marked.
Yeah, that is one of the downsides, that the package that they come in is marked, and but the things themselves. So if you've got a whole bunch of 0.1 microfarad capacitors to do, I think that's when it's useful to use the multiple method of you know, fit all of those and then move on to the next value. And I haven't come across an easy way to fix that. You can measure them, obviously. I've got a pair of tweezers that you plug into a capacitance meter, and if you just touch the ends of the thing, it tells you what value it is. but it's much easier to get it right first time. And as I say, I tend to fit all of one value and then fit the next ones.
Okay. When removing a bridge, do you need more paste to secure the legs?
I found not. I wouldn't say that's a universal thing, but my experience is that the surface tension tends to hold on to enough solder to make the joint. So when you remove it, it literally takes the excess away, but enough of it stays there.
Yeah.
And sometimes that's, you can go in with a conventional iron then and just tickle it up and make sure that it's a good joint. But I certainly haven't had any major problems following a desoldering episode.
Okay. And then getting into some of the equipment. In fact, there is a question here, and I'd like to supplement that. At what point is it worth building one of the tabletop ovens versus making do with a hot plate? It's trying to decide whether just to go straight to an oven or elsewise.
I've been doing SMD now for a few years, and I've never felt the need to go to the oven. I know, sadly no longer with us, but Dave, whose call sign escapes me, but used to be over in Suffolk. He was doing a lot of SMD kits and was promoting the use of ovens, and it worked really well for him. And I think Dennis has actually got Dave's old oven. Yeah, it works. But I think it's like any other tool. How often are you going to use it? And before you invest in it, you've got to think about, is it going to be useful, or is it just going to be something that sits in the cupboard and gathers dust? And I unless you were doing a lot, I think an oven is probably a step further than I would go anyway. But I can understand if you're thinking of gearing up, then go down that route. It certainly won't be a detriment to learning the process. Again, doing the solder paste thing, putting your components on, sticking it in the oven, I think was fine. And if that's where you want to go and you've got the space for it, yeah, why not? One thing I would comment on there, and I meant to put it in the presentation, but overlooked it. If you go and look on the web, you'll find all sorts of articles about temperature curves, where they'll tell you have to heat up to a certain level and then leave it at that level for a while, then give it a bit more heat and then control the cooling over a period of time. And if you're building a satellite that's going to go into orbit and I don't know, land guys on the moon or take them to Mars, that's probably true. For an amateur radio construction, I feel that that's perhaps going a little bit too far into the theory of what must be done as opposed to what could be done. And I may be shot down in flames by those who know more about this than me, but I've never gone down that route. If you're using a hot air gun or a soldering iron, you can't control the temperature to that degree. So why would you do it in an oven? But there are some very pedantic articles there that say you have to do this. Not been my experience, but so maybe I've been lucky.
Okay, and just to supplement that, there was a number of comments in the chat about magnifiers. Some were using like microscopes, some were using cameras, and as well as what you've mentioned with the head-mounted magnifiers. Can you expand on that a little bit?
Well, a very similar comment to the oven. If you're going to dive into this for the first time, I would suggest doing the cheap and cheerful version, and a pair of goggles will set you back about £10. And if you find that you really get on with it and you want to do more, then look at the alternatives. And I think microscopes, for me, are going a little bit too far. But again, if you want to use those really tiny pinhead components, then you're going to need something like that to be able to do it. But from what I've done, a simple head magnifier, or someone else had one of those things like it was on a desk on a bendable arm that was about the size of a large paperback book with a little LED lights either side, so you could look through it down onto the bench. That seemed to work really well as well. So lots of different ways of doing it. I'm not saying that the headgear is the way to do it. I'm just saying I found that a good introduction and manageable.
Can I
Yeah,
come in?
I'm sorry, Bill, go ahead.
Sorry, can I just come in there as well? I have one of the head ones. This is one of the proper ones. I got it in the States when I was over there. I've tried these little things that go in your eye that you see the jewelers using. There's something wrong with my eye sockets. They never stay in it. And I've tried even the shaped ones, and I still can't get them to stay. In the end, they fall in the board. One thing you can do, it's really cheap to try, and I find this really successful. I wear reading glasses, and what I've got is another pair of really cheap reading glasses. These are 2.5s. If you put them like that, you've got an astounding magnifier, which you can just shove up there when you're doing something normally. It's really worth trying if you've got a pair of reading glasses, something that's got the, Steve's are sort of a wider lens. My ordinary ones aren't too bad. These are quite narrow. So what I do, I put them on so I can still see at the top of my reading glasses. And here I've got this wonderful magnification, which is, I can get my hand in the right place. Now I'm magnified at that distance. I use that a lot of the time. Worth a try.
Yeah, what power are those?
These are they got on the side of them 2.5, plus 2.5. You can get these in the pound shops from 1.5 up to about 5. I've never gone that straight. I think my eyes would pop out. But these plus 2.5s work really well for me. And I said, you can get them in a pound shop or your 99-cent shops, and that's all you need. They work really well.
Yeah, and what I found too is I'll use my iPhone and use the camera on the iPhone, not when I'm soldering, but for checking joints and things like that. The magnification is just astounding if you can hold it steady enough for that.
Good idea.
Okay, going on. Can you speak about lead-free versus leaded solder? Probably with respect to SMD.
Right, this is my personal view. I would never use lead-free solder.
I'm the same.
I've tried it. I just don't get on with it, and I know people say you're not trying hard enough. It's perfectly legal to use leaded solder, certainly in the UK, for hobbies and for repair work. So why would you give yourself the grief of a lead-free thing? A little story about that. I did some work with the school, and they were most insistent that we had to use lead-free solder in the school. So we trolled along and said, well, if you're insisting on lead-free solder, you will have to provide it because I haven't got any. And they said, that's not a problem. And we turned up, the lab technician came up and he handed me 3 rolls of solder wire, and with a very theatrical wink said, here's your lead-free solder, Steve. And I thought, what's all that about? So I tried a couple of joints to see how bad it was, and it was wonderful. So when the school administrators had gone, I went to the technician and said, what was all that about, the lead-free solder? It feels more like lead solder. And he went, it is, but it's on a lead-free spool because you can't use lead-free solder very well. So I sit there for hours trolling the leaded stuff onto the spool. So he said, and nobody's any the wiser. So I won't name the school. I don't want him getting into trouble. But I thought that was a really good illustration that the powers that be insisted on something they didn't understand and didn't understand the risks. And you know, I'm from a health and safety background. I know for sure if you're working 8 hours a day every day in a soldering environment, lead is not a good thing to have around. But for a couple of hours on a school lesson, come on, guys, this is the real world. Come on. So yeah, we had some good projects. They all worked, and there were no dry joints that day, so it's good.
Yeah. Again, there's a bunch of wonderful comments in the chat about this and other topics. Going on to the next question, what would you use for cleaning excess solder and flux off of the PC board?
I've never had to do that. I don't think it's any different to any other solder or flux, but I literally I've never had to do it. So maybe I've been lucky, but again, if you're not too generous with the paste, it kind of, the surface tension holds it in place, and it doesn't go running all over the place. The solder mask on the PCB tends to look after that for you. So yeah, I can't comment on that because I've never had that as an issue.
Okay. Isopropanol is what I use if I've got any. It works. I used to use acetone, propanone, but I find isopropanol, which is a bit safer and much easier to get, will clean it off if you've got any excess on there, either with a toothbrush, if you've got stacks of it, or kitchen roll, or even those little things with the foam on the end, you know, with the cotton wool on the end to get it off. IPA, I think so. I think somebody on the chat room came up with that as well. Works very well.
Yeah, and one thing I found is that the isopropanol comes in different flavors, like 70%, 90%, and yeah, the 90% is much more effective.
That's what I've got. Yeah.
From Jerry, G0FUW, as we know, ICs, transistors, etc., can be prone to damage from excess heat, and some of these SMD components look very small and possibly prone to overheat damage. What's been your experience with this?
As I mentioned in the presentation, I've seen all sorts of damage inflicted on components by well-meaning newcomers. I don't recall any damage to SMD components in any of the build-a-thons I've done or the projects I've built myself. I say the biggest damage has been where they've lost the flipping things, and particularly if there's a carpeted room, it's a devil of a job finding them. But no, yeah, they are prone to overheating. Tends to be the things, I say, like polystyrene and things that have got a relatively low melting point. But if you think about it, these components are made to go in ovens in an industrial environment. You know, they're all picked by robots and put out and then cooked with the perfect temperature curve and all the rest of it. So yeah, I guess that's why they're fairly heat resistant. But you do get the warnings in the books and in the things that you can overheat things. I haven't had a problem with it.
Nor have I.
What's IPA? I noticed that in the chat, and it's not Indian Pale Ale.
Isopropyl alcohol.
Oh, okay. Okay, there you go. Okay. Any other questions? There were some comments in the Q&A while we were looking for questions. And if you've got something to ask, you know, we've got a few minutes left. Oh, they popped up right away. Sometimes the parts are added after the reflow process at a lower temperature to avoid melting. That's a comment.
Yeah, I can understand that. Yeah.
And then another, and this is actually about say if you're putting down ICs. John MOJF, has seen a technique about using solder ball beads for applying solder, where you put a solder ball at the end of your tip, and putting that down to try and solder these smaller leads.
Okay. I can understand that. I mean, I have the same reservations with that as I do with through hold components, that I'd much prefer to heat the pad and put the solder onto the pad, because I think as soon as you put it on the iron, you start losing the flux and all of that. But I can understand why you would perhaps want to do that, particularly if it's some fine work, that rather than trying to go in with the wire, you just a blob of solder that is just enough to coat the IC connector. Not a technique I've used, but I could see that might work.
Yeah, and I misunderstood his comment. He said, you get beads in a jar, and I'm not familiar with that.
No, that's a new one on me, but I shall look that up.
But I've used a solder bead on the end of on the tip of the soldering iron to take the lacquer off a magnet wire, which is a whole nother topic.
Absolutely.
Okay. Let's see here. I have no more questions, and
Okay, well, we're coming up towards the witching hour anyway.
Yeah, we've got about almost
5
5 minutes left.
I mean, what do people think? Would the an SMD kit be something that people would welcome in the QRP sales? I wonder.
Yeah.
Yeah, I'd make the comment that NorCal had done a variety of them in years past, and that's kind of how I got my start, was something simple. And what you referenced in your presentation is starting out with the dummy load kit, and that will tend to gear you up, get you tooled to go through some of the trial and error things of getting your working style when you put these things together.
I do remember now you've mentioned that with the one of the buildathons, we had a guy came along to try it because he'd never done it before and felt he ought to do it, and he completed the project, and his comment at the end was, "I've done that, I've completed it, I know I can do it, I'm never going to touch it again."
Yeah.
And that's fine, you know, it's not everybody's thing, and I you know, I wouldn't say that this is the way you've got to do things, but the message I'm trying to get over is that don't be frightened of it, give it a go, and you might find you actually enjoy it. A bit like Morse code in some ways. A lot of people shy away from Morse code, but when they try it, they find they actually enjoy it. And you know, I think SMD construction is probably one of those topics you'll either love it or hate it. But I think it's worth giving it a go.
Yeah, and G4EDX has mentioned that NorCal kit that I started out with was the SMK1, which was just a little DC receiver. And yeah, it was brilliant. And one of the things that it was smaller format. In other words, the kit that you had of the Sudden was spaced out, and the SMK was not. It was packed in there a bit, but it was good. It was good practice and such. So I'm sorry, the SMK was a transmitter and receiver. It was a transceiver. I'm sorry. Thanks for the correction on that. Got a couple more questions.
Before we go on to that, I know Dennis was working on some more SMD kits before he finished with Kanger. And I'd seen some prototypes, and I'm fairly sure they moved on the stuff that George had done at FDIM. So there was the RF probe, the oscillator, the PA, and the receiver board, low pass filter. So you could end up with a working transceiver with some fairly minimal practice boards, if you like. And if Paul picks that up and runs with it, then you know, maybe that's the route that we would do it, by selling those kits through the club sales or something like that, rather than doing it ourselves. Why reinvent the wheel?
Yeah, and I'll add to that too that both NorCal and also Steve Weber, K81JV, who had done the mountain toppers, the method by which they packaged these kits to be able to keep track of the SMD components, where they would use heat sealing packages and grids of components within the heat sealing packages, so that it literally give you a map of where the component resides in the bag, to be able to keep track of everything. And of course, the technique of, okay, if you have a whole bunch of certain ohm resistors, you put them all down at the same time, and stick with liked value components and get those down, make sure they're okay before you go to the next set of liked valued components. Which brings us to our next question. Tips on applying solder paste.
Trial and error. The first time I did it, I was being very frugal with it and just trying to be really accurate. The more I did it, the less I found that was necessary. You just get some on the board. I use the syringe. Some people buy it in pots and use like a paintbrush. I found the syringe was really good, actually. You just squirt enough on there. And again, when we used them at the buildathons, when people tried it, they didn't have any problem with that. They found it quite useful.
Well, and I'll supplement that question with, how did you do that at the buildathons? Did you use strictly paste or a combination of paste and hand soldering?
Yeah, what we did, we started with hand soldering, and then we had one hot air station. So as people got to a certain point, if they wanted to give it a try, they came across and used that. And so some people found they preferred the hand soldering, some people preferred the hot air, and some could see there was advantages in both. But I think it was just a good way of giving people the experience of trying the different techniques.
Okay. We're at our time right now. Let me just do one more question. Suggestions for organizing an SMD junk box.
I'd have to defer to Bill there, because I've gone down the kit road, so I get what I need.
I've used kits in the past, and I've got a jiffy bag, like a padded bag, with the strips in them when I bought the odd ones for projects I've done myself. The problem is, and I think it came up in Steve's talk, you can't tend to buy 1 or 2 capacitors. You've got to buy 100, but 100 probably only cost £1 anyway. So you keep them and make sure you mark them. The most important thing is to mark the strip that they're in, because they're in like a long bit of, it looks like a piece of packing tape, but very thin. Components are in there. Do mark that, because components and some inductors got no markings at all. And I just keep them together at the moment. It's probably safer like that than trying to take them out and put them in little bots. I hate using tweezers with them, because if they tweezers, they tend to ping out of them, and there's probably surface mount components all over my floor or in the carpet. But yeah, that's how I would keep them. Keep the strips and mark the strips. If you're not sure what's in them, take one out, take its value, and mark the strip. I hope that helps.
Yeah, again, there's some very good comments in the chat too about buying folders, putting them in binder notebooks, things like that as well. Anyways, we're at time. This discussion could probably roll over to the coffee shop under construction methods, if any of y'all wish to do that. But we're going to roll into the next presentation. I'm going to stop the recording. And again, this has been great. I think it's been a real good presentation. Thank you, Steve and Bill. And we'll move on.
Thank you.